Amber isn't just good for preserving mosquitoes with dinosaur DNA that can be used to clone dinos so you can put them in a theme park that kills people. It's also good for preserving things that don't kill anyone. Those preserved organisms make for incredible jewelry and home decor, but they're also incredible opportunities to learn more about the ancient world. So here are a few of the coolest things we've ever discovered preserved in amber. Amber is just fossilized tree resin, so it's technically not a mineral even though it looks like one. Trees and other woody plants secrete resin when they're injured in some way. That resin is sticky when it first flows out, and then it hardens into the tree version of a scab over the injury, acting like a band-aid to keep pathogens out while the plant heals. Sometimes these hardened chunks of resin end up buried in sediment. After about 40,000 years or so, the pressure and heat from being buried cause compounds in the resin to undergo chemical reactions that turn it into a rock-hard, transparent fossil. And for some reason, trees during the Cretaceous period were super resiny. We don't know why, but between around 72 million years ago and 125 million years ago, conifers just made way more resin than they ever had before or have since. So there's a bunch of fossil amber from this time period specifically. So if you notice us saying that a lot of the things in this episode are right around 100 million years old, that's why. There are several different types of amber that come from resins, all with different chemical makeups. And some ambers aren't amber at all, referring to color, and maybe not the color of your energy. They can range from yellow to orange to dark brown to green to blue, depending on what kind it is and where it's from. But we're not just interested in amber because it's pretty. It's what we found inside of amber that's most interesting, scientifically speaking. Plants, fungi, and animals end up wandering into the sticky resin or having it drop on them while they're just living their lives, and that resin hardens up pretty quickly, meaning all that soft and delicate stuff that gets stuck in the resin is preserved in perfect detail. We can even get clues about things that are hard to find in any other kind of fossil, like how animals behaved when they were still alive. So looking at fossilized amber gives researchers an opportunity to learn about the past in a totally new way. Take spiders, for instance. One of the coolest things about spiders is that most of them make silk from their butts. But spider silk isn't exactly a prime candidate for turning into a fossil through the usual route, since it's, fragile. However, researchers have found strands of ancient spider silk in amber, which is already super cool. And sometimes they even find prey insects still wrapped up in that silk, frozen in time just before they could become spider chow, which is a super bad day for the prey. Imagine you're going about your business, get trapped in a spider's web, think, well, this day can't possibly get any worse, and then you get encased in tree resin. In 2018, researchers found a tick stuck in this exact situation inside 100 million-year-old amber from Myanmar. For whatever reason, it's really rare to find ticks preserved in amber at all, so this was especially intriguing. It's also weird because modern spiders don't usually eat ticks. There's only a handful of spiders that are known to snack on these bloodsuckers, and even fewer actively hunt for them. So finding a tick in a spiderweb fossilized in amber was really exciting. The scientists aren't sure what kind of spider the web came from, since the spiders that we know eat ticks today haven't been confirmed to have been around way back then. It's also possible that the tick wasn't actually prey at all, but instead was a threat. Spiders have been known to immobilize potential predators by wrapping them in silk too, even if they aren't destined to become dinner. And as it turns out, we've found evidence of this in amber too. 100 million years ago, a showdown between a spider and a wasp ended rather abruptly when both were encased in resin mid-fight. The juvenile spider had a parasitic wasp in its clutches, still partially wrapped in silk to encase the foe. The spider in question had likely been waiting for hours for a snack to wander into its web, and resin encased them just before his patience paid off. In addition to the battle royale, the amber also contained another spider in the same web. This is the oldest evidence of social behavior in spiders, which is rare since modern spiders are more likely to cannibalize each other than share a web. So in this one piece of amber, scientists were able to get insights into spider friends and spider foes. On the flip side, amber has also given us a glimpse into nurturing behaviors too, like mothering, which is a complex social behavior that isn't exactly the easiest thing to see in the fossil record. But thanks to amber, we can see evidence of some bugs having a maternal instinct 100 100 million years ago. In 2015, a female scale insect was discovered preserved in amber with 60 eggs in a wax-coated sac on her abdomen, and 6 baby scale insects nearby. Before this discovery, we knew that some modern insects dig underground layers for their young and others carry them around on their bodies, but we had no idea when those traits evolved. So this fossil helped show that this behavior in insects is at least as old as the Cretaceous period. And we can't talk about behavior without talking about sex. Amber has preserved a lot of sex. In 2017, researchers discovered the 100-million-year-old equivalent of pickup artists trapped in amber. They found a male damselfly in Myanmar that was tiny but also had weirdly large legs. By comparing the fossils to modern damselflies, the researchers proposed that these massive appendages were used for courting. They hypothesized that the damselfly would hover in front of the females and wave the white interior sides of their legs in their lady damselfly faces, while the outer patterned parts of their legs scared off any potential competition. The damselfly also had a spot on its hind legs that was bigger than what you would expect to see if its evolutionary purpose was to intimidate predators. Instead, the researchers think this was also for attracting female attention, kind of like eye spots on a peacock. All of which suggests that damselflies evolved their elaborate, visually based courtship rituals at least 100 million years ago. And while they did all this for a chance at love, it may have also led to their demise. Overly large legs probably made them fly relatively slowly, making them vulnerable prey to the first birds, or more likely to get trapped in tree resin. And while we're on the subject of appendages, there's an amber fossil from Myanmar that preserved the oldest known erection in history. In 2016, researchers discovered a daddy longlegs with its penis fully extended. And I do mean fully, since it was half the length of its body. This particular group all have really uniquely and distinctly shaped penises. So much so that scientists actually use them to help distinguish between species. And this penis is not only the first one visible in amber, but it's also preserved with enough detail that the scientists could tell that it didn't belong to any species currently known. While it's possible that resin trapped this dude just as he was about to get it on, it's also possible that the erection happened after he got stuck. If he found himself caught in resin, started struggling to free himself, and his blood pressure spiked, that could have just as easily led to this somewhat embarrassing scenario. And some amber fossils get even more X-rated, as in the animals got trapped in resin while having sex. In 2020, a treasure trove of amber specimens dating from 40 million to 230 million years ago were discovered in Australia and New Zealand. And one of them included a pair of long-legged flies doing it. Catching animals in the act is super rare, even in amber, because it requires basically instantaneous death or at least complete trapping. Although it's possible that these flies actually weren't caught in the act, at least not at the same time. The researchers acknowledged that it's technically possible that one fly got trapped in resin first and the other decided to take advantage of the situation. Either way, it's the first known example of frozen behavior in the Australian fossil record and a look into the mating behavior of ancient flies. The whole collection was exciting for scientists because specimens preserved in amber are really rare in the southern hemisphere. And the crown jewel in this whole collection is fly sex. Talk about getting lucky. When it comes to rare fossils, you don't get much harder to find than feathers. They're soft, they're light, and they break down quickly. So it's hard to know who had them, who didn't, or what they looked like. There's been evidence of feathered non-avian dinosaurs since the 1990s, but that was just the impressions of the feathers, and we didn't have any actual feathers to look at. But in Myanmar in 2016, a 99-million-year-old theropod tail was found preserved in, you guessed it, amber. This feathery fossil finally confirmed what researchers had suspected for several decades. Dinosaurs, even non-flying ones, did indeed have feathers. Researchers have even determined that the amber preserved the amino acids in the feathers, so it's even possible that future research can analyze their molecular structure. Our last rare fossil is from a lot closer to home, specifically New Jersey, and these Garden State fossils solved a decades-long debate in the study of ancient ants. In 1967, researchers found 2 worker ants preserved in amber in New Jersey, a find which pushed the origin of ants back to over 100 million years ago. However, not everyone believed that these tiny critters were really ants. See, most researchers thought that ants only evolved after the dinosaurs went extinct 66 million years ago, so finding 100-million-year-old ants was a bit of a leap. Instead, they argued that the oldest ants were just 40 million years old. So the actual age of this massive insect group was kind of controversial for decades, until 1998, when more ants were found in New Jersey amber, and these were 92 million years old. The find moved the origin of ants back at least 50 million years further than we thought, and drastically changed what we know about their evolution. Specifically, it means that ants are among the lucky 20% of animal groups that managed to survive the end Cretaceous mass extinction, which is great for them, but a little annoying for me when I'm trying to have a picnic. New Jersey amber itself isn't just found in New Jersey, but all along the east coast of the US. And if you're a SciShow Rocks Box subscriber, you'll get your very own New Jersey amber shipped right to your door this month. Give it a look, maybe using your SciShow jeweler's loupe, and see if you can find any record-breaking bugs in there. If you're not a subscriber and you want to learn more about the subscription, our jeweler's loupe, or our premium offerings, visit scishow.rocks. Thanks for watching.